Calculus Kids. This is Dr. Callahan with week 1 Friday. Congratulations, you made it to the last day of the first week. So go ahead and pause the video and ask the following 3 questions on your warm-up log. All right, so yesterday I had Noah that said I was checking my options for next year and it was not letting me choose either Calculus BC and he's not sure what to do. So I did contact the counselors and they went ahead and updated the forms. So you should be able to log onto Infinite Campus and then select the classes that you need to go ahead and choose. So most likely if you're not a senior this year, you want to go to Calculus BC. It's a second year of calculus. So make sure you do that. And if you're having any difficulty, you're welcome to contact me on email or MS Team because I would be checking both. All right, so let's go ahead and create the assignment for today. For week 1, Friday, and it is for calculus. AB semester 2. Our topic of discussion today is going to be on Reiman sum. And your instructions. Is to go ahead and watch the video. Make sure you guys watch the video in its entirety, do the warm-up. It should be equivalent to 55 minutes of instructions. Actually, according to your schedule here, it's actually not 25. So it's actually 40 minutes of instruction. Here we go. Sorry, let's change that. And then the 2 links that you need for this class is your calculus link for the videos and then also the Google Doc. If you need hard copies, you're outside my door and this is your schedule. It is from 9:20 to 10:05, so make sure you check in with me but during that time frame for your attendance. If you have not been watching the videos or keeping up to date with the different assignments each day, make sure you are doing that. You have 5 assignments per week, so you need to make sure you click on the assignment for your attendance purpose, but then also watch the video so that way you understand what our notes is and then follow that along with the guided notes that's provided for you. Some of the key highlights of what's due this week is that you have your Math Excel for week 1. You also have your AP College Board that was from Wednesday. So those are the 2 things that you definitely want to make sure you complete because over the weekend I am going to be updating your grade with those 2 assignments. All assignments are due by 3:30 p.m. Although if you do turn it in late, that is acceptable. It is fine. But just as a rule of thumb, you want to do it and complete it within the day that it's due. And I'm just going to go ahead and assign this. All right, so then let's go ahead and take a look at your guided notes today. So it is for week 1, Friday, and it looks something like this. And for once, I mean, believe it or not, it's only actually 2 pages, which doesn't really happen. I always have like 5 pages or something, but yes, it's only 2 pages and it looks like this. Today, we're going to start off with Reiman sum. We're taking a little break on integrations. And Reiman sum is actually what you do to find the area underneath a curve. And when I say curve, I'm talking about if you had a parabola that looks something like this, like a U shape, and you're looking for the areas underneath it. It's not typical to find the area of that because you've learned how to find the area of a triangle, a rectangle, square, etc. And this with a curve is a little bit more difficult. So this is where Reiman sum comes in. And today is going to be the first day of several days when we're talking about this topic. So here's the first page of it. We're going to go over 7 different examples. And then on the back are some examples from your textbook that I went ahead and set the steps and also the answers for you guys for additional practice. So what I'm going to do with this is I'm going to go ahead and post this on a separate PowerPoint. So that way, if you don't have a hard copy at home and you don't want to print out everything for the entire 9 weeks because there's 156 pages and I don't want you guys to waste your ink cartridge because they're expensive. You can just print out the stuff just for today specifically for week 1 Friday, and it's only 2 pages that way. So let me go ahead and save this for you guys for week 1 Friday. And it'll be on a PDF. Save. Okay, so I just want to make sure that this assignment pops up so you're able to see it. And let's go ahead and attach that. Perfect. So if you go and click on this, then this is what it looks like, and you will have access to the PDF for 2 pages. Okay, you guys, let's continue on with our notes today. All right, so the third question here asks you about how do you find the area of like a trapezoid, for example? I mean, you know the formulas for a rectangle, length times width. You know the area formula for a trapezoid back in probably grade school, but also in geometry, it's just base 1 plus base 2 times the height times by 1/2. But then the reason I'm asking you guys about this is in case you have like a curve that looks something like this, if I ask you to find the areas underneath the curve, if I can break this little pieces, break this area under the curve into like, let's say, a bunch of maybe rectangles or trapezoids. So there's one trapezoid. Here's another trapezoid. Here's another trapezoid. And I find the areas of these trapezoids and I add them all together. Then what it creates is the area of somewhat of a estimate of the area underneath this curve. Okay, and that's what the Reiman sum is you're adding the area of a bunch of trapezoids, or it could even be rectangles, you know. So we'll talk a little bit more about that. Last time I saw you guys, we did go over the following. We went over your guided notes with the textbook. We went over 5 questions in class, and then I asked you guys to kind of practice with the remaining ones on your own with the video itself. So make sure you guys took a moment to answer that and it's completed. In addition to that, you also had little squares that was testing you on your skills and ability to find the integration, and also a mixture of integration in addition to derivatives, because on the AP exams you guys will have both. So I wanted to make sure you guys were able to decipher the difference between the two. So we did that. Today we're going to start with Reiman sum, and this is kind of the breakdown of what we're going to be doing. So Reiman sum, another way of saying that is sigma notation, and we're going to go over 7 examples. And this will be our first day. Okay, you do need to, however, have a calculator, so just keep that in mind. Okay, let's go ahead and get started on the first page right here. Okay, sigma notation is this interesting looking E-shaped symbol. Okay, it always have something that you start off with and something that you end with. And there are several things that you need to know. The first one here, the 5, is the upper bound. That's kind of where it's ending. The lower bound is on the bottom. So you start at 2, end at 5. The I stands for index. And so if I look at example 1 and my lower bound is a 2, and then my upper bound is a 4, and my index is I equals 2, then I start off with 2 squared plus 1. That's my first one. And then what's after 2, that's in between 2 and 4, it'll be 3. So then I replace the I with a 3. So 3 squared plus 1. And then afterwards, my last one is 4. So 4 squared plus 1. And that's where I stop because that's my upper bound. So then using PEMDAS, I'm going to do the exponent. 2 times 2 is 4. 4 plus 1 is going to give me a 5. 3 squared plus 1 is a 10. 4 squared plus 1 is a 17. And I add everything together, and my answer here is 32. So that's an easy portion of the Reiman sum. So just starting off pretty simple for the most part. All right, then let's go ahead and jump in with something else, okay? So notice the summation formulas, there are 5 different types. You must memorize these formulas in order to use them, and you're going to be matching them to the equation that you're going to be modifying on the example, so that way you can use these summation formulas. And I know you're thinking, well, why can't I just keep on doing something like this? It doesn't seem like it's all that bad. But then again, this is something that's fairly simple. Eventually the equations that you get will be not as simple and it'll be relatively difficult. And if you have something that looks like this that you have to do from, let's say, like, from 1 to 100, I mean, that would just take forever. You know what I mean? Because you're adding them systematically one by one. And so it's easier if you go ahead and modify the example that you're given, change the formula so actually meet either number 1, 2, 3, or 4, and then be able to use the shortcuts of the formulas that they provide. It will make sense as we go along with this, I promise. Okay, so let's take a look at example 2. And notice that I have the summation formulas right there, so that way you guys can easily match them. So for example 2, I have 3i squared plus 2. So looking at that right there, which summation formula do you think that will most likely match? And if you're not sure yet because you can't see yet, that's okay. I mean, like, eventually you will have to match them before the end of the problem. So let's go ahead and maybe rewrite this a little bit. So here I have the summation of 8i equals 1. And I could go ahead and break this apart. So I have a 3i squared plus the summation of I equals 1 to 8 of a 2. Now, immediately as I'm looking at this right here, I see that I have an I squared, and I also have an I squared right here for formula number 3. So then I could probably use this equation that's given to me to help me simplify that. So what do I do then? I will go ahead and move this 3 in front because it is a constant. So 3 I squared plus, I can also move this 2 in the front because remember, this is just 2 times 1. So if I move the 2 in the front, I still have a 1. And so with this 1, it looks like it matches the summation of formula number 1. So then let's go ahead and do this. 3. Now, if I were to match this part here to this formula right here, notice that my n is going to be right here. My n in this case is 8, n plus 1. So that's going to be an 8 times n plus 1. So 8 plus 1 is a 9 times 2n plus 1 is 2 times 8 is 16 plus 1 is a 17. Okay, divided by 6, and it's always going to be 6. And that's my first part. Plus, then do not forget your second part right here, where it's a summation of 1. So you're looking at this formula, and it's just equal to n. And what is your n again? Your n is 8. So don't forget your 2. 2 times 8. So then grab your calculator. You want to go ahead and multiply this out. 8 times 9 times 17 times 3 divided by 6 is going to give you 612 plus 16. So your answer here is 628. So if you're to find the area underneath a curve of something, this is a summation notation form that you use to do that. All right, let's go ahead and take a look at example 3. If you feel confident of working on number 3 by yourself, you're completely welcome to pause the video and try it on your own. But if you don't feel confident with it, that's okay. We can work on this together. All right, so for example 3, you have a FOIL problem. And the reason for that is because there is no way you can match the I plus 2 squared into any of what's given to you here. I mean, there's just nothing that you can really match. So I would have to FOIL this. So FOIL. First is just going to give me an I squared. Outer is going to give me a 2I. Inner is going to give me a 2I. Last is going to give me a 4. Combine your like term, that's 4I. So I have the summation starting at I equals 1 to 10 of I squared plus 4I plus 4. And then you probably guessed it, you would have to separate them. So then I would have to use 3 different summation formulas to match. So then my first one is I equals 1 to 10 of I squared plus a summation I equals 1 to 10 of 4I plus a summation of I equals 1 to 10 of just 4. And then as you can see here, the first one, you can just match with this one right there. And also you should probably realize, like just like last time, we always move the 4 over in the front. And we'll move this 4 over the front with a 1 right there. So we're most likely going to be matching the I with this I and matching the 1 with the formula with this 1. All right, so let's proceed with this. So then to replace the summation, so I don't have the E, the sigma notation there, I'm going to use I squared. Keep in mind that your N is 10. Okay, so then in this case, it is going to be an N, which is a 10, times N plus 1, so 11. 2 times 10 plus 1, and then 21, all the way over 6. That's your first part. Then your second part is going to be I, so that's going to be formula 2. Your N is a 10 again, so 10. N plus 1 is 11, divided by 2. And then lastly, you have 1, and that's just N, so that's just going to be 10. So grab your calculator, let's go ahead and do this. 10 times 11 times 21 divided by 6 is going to give you a 385. 10 times 11 divided by 2 is going to give you 220, and then plus 10. Altogether, your answer is 645. All right, let's go on to example 4. Now, if you feel like you're comfortable with example 3 and you want to pause the video and try example 4 on your own, please feel free to do that. All right, so looking at example 4, I'm going to be separating this as I did before. If you look at this, you have a 1 in, so 1 over n. So you're going to have to distribute that over. So you have a 1 over n k squared minus 1 over n times negative 1, or times 1, I should say. So then if I were to separate this, I will have a 1 over n e k equals 1 to n, oops, times k squared, and that's just the first part right there, minus 1 over n e k equals 1 to n of 1, and that's the second part right there. So then here I have k squared, so I will be using this formula right there, except instead of putting down I have k instead. So then the first one, as I replace the k squared with I squared, is 1 over n times n times n plus 1 times 2n plus 1 divided by 6 minus 1 over n times n. Looking at this, I noticed that this n and the denominator n can be canceled, and also I could do the same thing over here. So then I'm left with n plus 1 times 2n plus 1 over 6 minus 1. I would have to FOIL the numerator here. So if I FOIL this, you're going to get first is a 2n squared. Outer is a 2n, inner is a 2n. I'm sorry, 1n is the outer, 2n is the inner, so that's a 3n. And then last is a 1 times 1, which is just 1 over 6. And because you have a 1 right here, the same thing as saying a 1 is 6 over 6. So let's just make sure we have common denominators. And then if I combine this, I have 2n squared plus 3n minus 5 over 6. And that is my answer. All right, so then let's go ahead and go on to number 5, 6, and 7. And if you feel comfortable with it, you're welcome to go ahead and proceed forward and try that on your own. But if you don't feel comfortable with it, we can definitely go over this together. All right, I'm still setting this up. Okay, so let's go ahead and proceed forward. Okay. With example 5, if you look at this right here, it says if s of n equals 1 over n squared and n times n plus 1 over 2, then find the limit as n approaches infinity for s of n. So first thing I'm going to do is I'm going to go ahead and distribute this n. So I have an n squared plus n. And then also I have over 2 times, actually before I distribute that, this should be a little bit better. I could probably take this n because that's n times n, cancel it with this n. So I have a 1 over n times n plus 1 over 2. And then if I multiply this through, it'll just give me an n plus 1 over 2n. So then as I look at for this for my limit, I am going to have the limit as n approaches infinity, n squared plus over 2n squared is going to equal, and if you look at this right here, you guys, this is kind of similar to when we have the horizontal asymptote, where as if you look at the exponents, because n is approaching infinity, and you're looking at the coefficients and these are exact, I'm sorry, the powers, and they are exactly the same, then you're looking at the coefficients. So it's just 1 over 2. And that's your answer. All right, example 6. As x approaches infinity, you have 2I over n times 2 over n. So if I were to multiply this together, that will give me a 4I over n squared. And so I'm going to plug this into the sigma notation. So I have the limit as x, or n, not x, approaches infinity. I equals 1. I'm going to go ahead and break this one apart because I just want to have the I by itself. So then I can go ahead and just rewrite this as 4 over n squared, put that on the outside, and then times I. So I'm going to have 4 over n squared, I right there. So then I can go ahead and proceed on with this formula. Okay, so that's going to give me the limit as n approaches infinity, 4 over n squared times, what's going to end up happening here is that my upper limit here is n, and I know that it is going to give me a replacement of the I is going to give me an n plus 1 times the n on the outside over 2, which is just this part right here. And then if I go ahead and distribute this, I have 4n times n, which is a 4n squared. 4n times 1, which is just 4n, over n squared times 2 is 2n squared. And given the fact that n is approaching infinity, you can use a horizontal asymptote rule. And since both the top and bottom exponents are exactly the same, you're looking at the leading coefficient, which is just 4 over 2. So your answer is just 2. All right, last one, number 7. So let's take a look at this one here. So with this one, you will have the FOIL, the first part of 1 plus 2I over n, 1 plus 2I over n. And if you FOIL this, what's going to end up happening, is you have first, which is just 1. Hold on a second. Let's go back to this. It's not extended. It's just 2I over n. Okay, so then plus first outer, so that's your first. Your outer is going to 1 times that, so 2I over n, plus the inner, so 2I over n, plus the last, which is going to give me 4I squared over n squared. These two can be combined, so it's 1 plus 4I over n, because they already have the common denominators, 4I squared over n squared. So rewriting this entire thing, you have this piece right here, but don't forget the 2 divided by n. So 2 over n. I will have to distribute that 2n into this, which will then give me 2 over n plus 8I over n squared plus 8I squared over n cubed. And remember, this entire thing, you still have the limit n approaches infinity with the sigma I starting on 1 to n. Okay, so then I already kind of see where I'm going to be having this. I see that if I could go ahead and take out the 2n, I have a 1 right there, so that will give me this part right there. I also have the I, so I'll be using this formula right there, and also have the I squared. So what that means is I am going to have 2 over n on the outside. And then this 1 will give me an n, so times that by n. plus 8 over n squared with this I. This I will give me this part here, and that will give me an n times n plus 1 over 2 plus 8 over n cubed times I squared is going to give me this entire thing right here. So that's n times n plus 1 times 2n plus 1 all the way over 6. Okay, so let's clean this up a little bit. I know that I can go ahead and cancel this in with this n, which will have an n on the bottom left, and then this n with an n squared on the very bottom. And of course this n with this n. So I'm gonna rewrite my answers up here because I'm running out of space. I will just have a 2 left, plus if you take a look over here with this n and this n, notice, oh shoot, I'm gonna keep that. No, what's going on? Come on. Okay, there we go. Then what's going to end up happening over here is, remember, as the limit approaches infinity, so this n and this n, they have exactly the same exponent of 1. So you're looking at the leading coefficient, which is 8 divided by 2. So I'm going to put 8 over 2. Plus, looking over here, you have a 2 with the 8. So 2 times the 8 is 16 over 6. 16 over 6. And if you have a 16 over 6, you can reduce that by 2 to an 8 over 3. And that's after we apply the limit. So then looking at this part here, if you can go ahead and find the common denominator, that gives me a 4. If I were to make this a 3, that will become a 6. If I make the denominator here a 3, that'll become a 12. 6 plus 12 plus 8 is going to give you 26 over 3. And that's your answer. Whew, that was a little bit long. All right, you guys. So that's basically all that I have for you. So later, if you would like some additional practice, what you can do is take a look over at this link right here. It says need more examples. Here are Dr. C's notes. You can go ahead and go onto that, or you can go and practice with the textbook of these questions that I have, and the answers are given to you. All right, well, I hope you have a wonderful day, and as always, stay safe and healthy, and I'll see you guys on Monday. Take care.